Welcome to One Chemistry. Always try to do your best. Now let us see about 100 conversion in organic chemistry. We are seeing it as episodes. We are progressing. This is the episode number 99. If you didn't watch previous episodes, I encourage you to go and see. Here we solve 5 problems step by step. Stay tuned. Let us see the question number 1. The starting metal is linear system attached with ketone and aldehyde. You have phenyl on the other end. So the ketone and aldehyde possibility, but both have carbonyl. You are using phosphine as the reagent which is attached with COOET. They ask you to find the product. The question is the alkene is formed, whether alkene is cis alkene or trans alkene, or the reaction happened at the aldehyde or ketone. So there is a competition between aldehyde and ketone as well as the alkene conformation. So from the reactant to product you might guess the competition between aldehyde and ketone, and definitely the naming reaction is involved. The answer is C. Let us see how. The starting metal you have aldehyde and ketone. If you compare the reactivity of carbonyl, the aldehyde is very reactive than ketone because the carbonyl positive charge is reduced by ketone. Why? Because the positive charge is quenched by the electron donating methylene group, or you can say here it's a phenyl group. Phenyl withdraws the electron due to its resonance. So the charge density or the charge living on the carbon is less there. So aldehyde is obviously very reactive. You are adding the reagent with the phosphine. So aldehyde is the reacting center and phosphine. So you might think of Wittig reaction. Wittig reaction converts CO into CC bond. It's basically a pH3PO elimination. So elimination of phosphine from the system to get the alkene. Here the question is that whether the E alkene or Z alkene will be formed. Here E alkene will be formed. Let us see why. Why? Because if the halide is stable, the alkene will be on E position. Because the stable halide has long lifetime, so it converted into stable E form or thermodynamically stable E form. The stability we claim is the electron withdrawing ability of COOET because it is near the negative charge. So withdraw the electron, stabilize the negative charge there. So it's a stabilized halide there. Here you have to learn two important things. One is reactivity between aldehyde and ketone. Aldehyde is very reactive when compared to ketone because the ketone has two electron donating group reduce the positive charge. Second thing is Wittig reaction. In Wittig reaction, stable halide always form E alkene. Then the question number 2. The starting metal is cyclooctatetraene and you are using anhydride. You are continuously heating that. They ask you to find the product. The products are fused ring system. How the fusion is occur, whether bicyclic system is formed or direct fusion, or the dimerization happen, or the ring expansion happen. 4 possibilities. So from the reactant to product you might guess the possibility of ring contraction as well as the ring fusion. The answer is A. Let us see how. Starting metal is cyclooctatetraene you are heating. So definitely the chances for pericyclic reaction. Here only 6 electron is involved. So 4 and plus 2 5 electron is there, heating condition. So definitely disrotation. Disrotation always lead to syn hydrogen. So syn hydrogen is there and alkene is there. So you have the system contain conjugated diene and alkene. Next step you are reacting with anhydride. Anhydride will act as dienophile. The previous product acts as diene. So reaction between diene and dienophile, definitely the 4 plus 2 cycloaddition is possible because same thermal condition. So the 4 plus 2 cycloaddition occur, 4 5 become the bridged carbon. So the 4 member ring become bridged there and directly anhydride is attached, which is product clearly A. Here alkene attack the 3 6 position, 4 by carbon become bridged one. Why the other possibilities are not there? Because the reaction is always between diene and dienophile. No dimerization is possible because you have ready dienophile. Here you have to learn two important things. If you have pericyclic electron, you think of pericyclic reaction. Here 4n plus 2 pi electron disrotation. Second thing is 4 plus 2 cycloaddition, which is a thermal bond. It always occur between diene and dienophile. Then the question number 3. The starting material is straight chain system with nitrogen, which is in azo form. You are using the light. There is the two products are asked, which is P and Q. The P and Q are, P is the intermediate, Q are the product. The P can be radical and carbene. 4 products are given by the choices. B can be carbene or radical. Q can be the butterfly kind of system, or the straight chain with alkene in the end or middle, or just a cyclopropanation. The cyclization at the end happened or not. So there are the 4 possibilities. So from the reactant to product, you might guess intermediate here is important, and the quenching possibilities define the 4 products. The answer is A. Let us see how. The starting material you have azo compound. It's a very good leaving group. It's normally the preparation of carbene. Even a small trigger, even a light break the N2 bond. So the N2 bond can be kicked out of the system by mere light shining. So N2 leaves, carbene is formed. Why the carbene is formed? Sudden removal of 2 electrons from the system. So that's why carbene here. The carbene can be rewritten for the product. So we write it as bend form. Then how the carbene will be quenched there? Carbene will be quenched as a butterfly kind of system. Why? Because this is possible. This didn't involve any elimination or addition. The all valencies are satisfied. If you go for other products, you might think of rearrangement or hydrogen shift. So the only possible structure is butterfly structure, which is the bicyclic propane, which is answer A. Why the nitrogen is a good leaving group? Because nitrogen formed triple bond. Triple bond is very stable, it losses, it forms the carbene there. Because sudden loss of 2 electrons leads to the intermediate carbene. Here you have to learn 2 important things. One is carbene formation. The carbene formation formed from the azo compound. The sudden removing of nitrogen leads to the carbene. Second thing is quenching of the carbene. Here the butterfly structure is possible. This quenching didn't involve any elimination of hydrogen or the isomerization. Then the question number 4. The starting metal is benzene, which attached with O-alkyl system, which is O-allyl, where the first carbon is labeled, which is marked as asterisk. You are heating. They ask you to find the product. The products are para form. So from the reactant to product, definitely you might guess rearrangement is occur, and position of labeled carbon is important here. The answer is A. Let us see how. The starting metal you have O-allyl system, so you can redraw to the 6-member ring kind of architecture because you can involve 3,3 sigmatropic rearrangement. So the electrons are more. You got the ketone there with side chain allyl. Here aromaticity is gone. Again next step it going up. The driving force is aromaticity for the next step. So again the bonds are moving. Here you have to watch the position of the labeled carbon. So again the rearrangement occurs because aromaticity has to be established. So again the 6-member intermediate is possible, rearrangement occurs. So the labeled carbon come at the middle, which is in the 6th position. Here numbers are given for understanding. There is no scientific meaning behind it. So the consecutive 3,3 rearrangement occurs and the isotope come in the middle, which is product A. Here you have to learn 2 important things. Whenever you have linear side chain which attachment of O, you might think of 3,3 sigmatropic rearrangement. Here rearrangement continuously proceeds to establish the aromaticity. So system always move towards the stable form. Then the question number 5. The starting metal you have to live in and you are using anhydride. You are using excess of aluminum chloride. They ask you to find the product. The product can be ring fusion or the dimerization or just attachment or the dimerization and the different position, the regioselectivity. So from the reactant to product, definitely new carbon-carbon bond is established and ring closure possibilities there are not is the real question. The answer is C. Let us see how. The starting metal you are having anhydride, you are using aluminum chloride. What aluminum chloride do is, it bonded with oxygen. The aluminum chloride activates the carbonyl because it pulled the electron from the system. Carbonyl get more positive charge, so it is possible by charge traveling and mesomeric effect. So finally, cation formed in the carbonyl. It's a symmetrical system. You can start from any carbonyl. You can get other carbonyl as a electrophile. Then you are attacking with benzene. Due to the steric reason, para position is major, so the attack is happened. Here next thing, why there is another possibility? Because you have another acid is there, the reaction is stopped because the electron withdrawing group CO withdraw the electron density from the benzene, so benzene become less nucleophilic. The reaction is stopped there, which is product C. Here you have to learn two important things. One is aluminum chloride role. Aluminum chloride here just activate the carbonate like Friedel-Crafts reaction. Second thing is only para attack is possible due to its steric effect. Further, the reaction is not proceeded to the dimerization or ring closure because of decreasing electron density in the benzene. That's all from this episode. I hope it was easy. Thanks for watching. If you have any suggestion, comment below. Stay tuned for next episode.